Good day, and welcome to today's on-demand webinar from Expedera entitled Cautions of Designing Your Own NPU. Could a third-party solution be a better option? Before we get into the subject matter, let me first introduce Expedera and myself. Expedera is a Silicon Valley-based startup designing optimized AI inference IP based on our revolutionary packet architecture. I know that's a bit of a mouthful, and we'll get into that a bit later in the presentation. As I mentioned, we were founded here in Silicon Valley in 2018 and did our Series A in 2021. We have 3 R&D centers around the world, as well as numerous granted and applied for patents. We're shipping our 3rd generation NPU architecture already, and we are silicon proven. 8 million devices in the field exist today with Expedera, and of course that number grows by the day. And finally, my name is Paul Karazuba. I'm the Vice President of Marketing here at Expedera. So let's get into it. Let's first talk at a very high level. Why do you need an NPU, or a neural processing unit? Well, first, neural networks typically need billions of compute operations per inference. General purpose architectures, whether they be CPUs or GPUs, fail to meet the power, the thermal, and the latency needs of real-time AI deployments. Heterogeneous architectures with specialized coprocessors are the obvious choice for achieving the maximum compute per watt, especially when we look at edge AI applications, whether that be home appliances, whether that be a smartphone, or even a car. A heterogeneous architecture is going to be the way to go. And it's going to be done via an NPU, a neural processing unit. An NPU is a specialized AI processor, and it enables chip architects and system architects to optimize the area, the power, the performance, and the accuracy by putting in a specialized processor specific for neural networks. Now, the question that comes about when a system architect or a program manager is looking at the next generation design, the question will frequently come up, should I design my own NPU, or is an off-the-shelf NPU a better option? So let's first explore, why do companies consider doing in-house NPU design? So let's walk through some of the high-level reasons why companies may consider designing their own NPU in-house. Start with something very simple. Why not? Yeah, it could be a learning experience for my team. I could gain a competitive advantage versus my competitors. And it could be faster or better or cheaper than what I may be able to find elsewhere. Now, some of the specific things that we hear is, I want a highly differentiated feature set. And that may be a reaction to some of the very general purpose NPUs that are available in the market that don't offer any differentiation. An interesting one, building an NPU increases the value to my investors. I want to control my entire software stack. We hear this a lot. My team is great, or my team needs work. And those are certainly legitimate questions and legitimate statements to say in reaction to why I might be wanting to build my own NPU. But let's step back and let's look at first some of the internal complexities that might come with that decision. And we're going to look at this from the perspective of 3 different groups or people within an OEM. We'll start with the SoC architect, then go to the developer, and then finish with the product manager. So an SoC architect is really going to be looking at designing a potential NPU as part of developing an entire chip, which is obviously going to include more than just an NPU. It's likely going to include a CPU, multiple other ancillary technologies on the same chip. They're most likely going to be interested in what will a plausible solution look like for developing my own or designing my own NPU. And they're going to look at it around the aspect of, what are my design targets? What is my processing architecture actually going to look like? And what design parameters am I going to be faced with? Now then you move to the developer. And the developer is the person actually implementing this in the silicon. They're going to be looking at, can it even be built? Is it going to meet my design goals? They're going to be thinking about accuracy, about system bring up, about specification adherence. And often those may be slightly at odds with the initial thoughts of the SoC architect. And then we move to the product manager. The product manager is going to be concerned with, is this product, is this chip, is this system deployable? What kind of SDK and development tools am I going to need to provide to my customers? How am I going to future-proof my product to make sure that the product that I release today is going to support the networks of tomorrow? Because have no illusion about this. Neural networks are advancing much faster than silicon is advancing. And all product managers, and indeed anyone developing chips with NPUs, needs to be cognizant of that and needs to be looking at the future. But as we step back and we look at the three different stakeholders that we have here and what their individual goals for a system are, they can often be conflicting with each other, which makes the idea of developing an NPU a little harder, because trying to build consensus among these people from a ground up design can often take a very long time and can often delay projects, often to the point of them not being feasible to release into the market. So let's jump to the idea of, is designing an NPU easy or straightforward? Well, it is, if you assume 5 big items that, frankly, you cannot assume. You may assume you have sufficient bandwidth. Well, our experience is that bandwidth is something that is always in need. You may assume you have sufficient area on your chip. Well, if you don't have experience designing an NPU, the size of your NPU is going to grow significantly. If you haven't nailed down your specific networks, you may be developing a more general purpose NPU. That is going to grow the size of your NPU as a function of silicon area dramatically. You may assume you have isolation. You probably don't. You may assume you have a narrow workload, meaning I'm only going to have to run one network or two networks. But as we mentioned in the last slide, neural networks are advancing quickly. You need to assume that you are going to have a much larger workload than you anticipated, especially over the life of your product. And a real big assumption that many people seem to make and always comes back to bite them is the idea of software. Software in an AI stack is as important as anything that is done in hardware. Software co-development with your hardware is absolutely imperative to any sort of successful NPU design or successful NPU deployment. And let's move to the future. As we've entitled this slide, the future is a moving target. The left-hand side of the slide is a graphical representation of the number of operations, the number of waits, and the number of activations that 5 commonly used neural networks present to chip designers today. As you can see, there is no correlation between any of the three with each other, meaning that certain networks, let's use the yellow, the FSR CNN, has more operations, significantly more than any of the other, as well as has the most activations, but has so few weights that it's not even shown on the graph. When you look at YOLO V3 in orange, a minimum amount of activations, but the most number of weights by far compared to the other. What I mean by showing this is that there's very little correlation between networks and their actual workloads. And those are simply today's neural networks. Tomorrow's networks, and quite literally, in some cases, I mean tomorrow, they're going to have deeper layers. They're going to be larger. There's going to be dense connectivity between these layers. So our caution here, and the reason that we show this, is that it is absolutely imperative that any NPU that you design or that you choose has to have layer support, has to have high accuracy, but also has to have high utilization. And these often are not workable together in standard designs. So let's jump and summarize some of the key risks that we see that are overlooked in NPU design. First, architectural modeling. How accurate is your power measurement going to be without real silicon? And can you trust your modeling tools, if you have them, to provide accurate results? And how accurate is your performance going to be without your determinism? Extensibility. We've talked about this. How do we and how can we accommodate unknown future uses of the chip or the product that I am designing? And of course, if you're thinking of designing your own NPU, you're probably not thinking about a single generation worth of design. You are most likely assuming multiple generations building on the same architecture. One of the risks that we see is, can you scale your design for future product platforms? From an integration point of view, how does an NPU that you might design interact with other components and shared resources on the chips? It takes experience and expertise to do this sort of thing. Anyone who's designed an SoC, especially a larger SoC in a latter generation process node, is going to tell you rather that it's not as simple as just laying things out on a chip and having them talk together. The intricacies of communication between blocks on a chip are high. And this is a very large risk that you face, especially if this is your first time designing your own chip. And finally, one of the most important risks, or one of the biggest risks that you face, is schedule. Building a new architecture, integrating it into a new SoC, and getting it out and released is a significant schedule risk. And being in marketing, one of the most important things that I say is my time to market is often one of my biggest competitive advantages. And are you willing to risk significant delays in your product to build on an unproven design? So let's pivot to how you might analyze or evaluate third-party solutions rather than build your own. And obviously, Expedera, as an NPU IP supplier, is biased in the subject, thinking that third-party solutions are certainly going to be better for you. But let's talk about how, as you're going through the process of choosing to either design your own or source a third party, questions or evaluation methods that one might make in third-party IP. So first, we're going to use the same 4 topics we used on the previous slide. Start with architectural modeling. You want to look at how valid is the power, performance, area, and accuracy simulations versus real deployments. Is there cycle accurate modeling? Let's look at extensibility. You are going to want to evaluate your third-party solution for how easy it is to adopt new network architectures. Ask the question specifically of a potential third-party supplier. How do you support future networks? How do you support future networks that I, as an OEM, may build or may be available from other parties? Also ask the question, how do you support custom networks? Because this is an emerging trend that public models are also being supplanted by custom design models. From an integration point of view, does the software stack that a third-party IP supplier enable heterogeneous SoCs? How easy is it to use? How can you take that software and use it for your purposes? And finally, on the schedule point of view, is the IP silicon proven? This is an incredibly important benchmark. Have the third-party provider either put it into their own silicon, or even better, has it been deployed in customer silicon? And has it been adopted for similar applications? All of these questions are questions that you should be asking of third-party potential suppliers to ensure that the product or the IP that they offer is what you're looking for. So speaking of IP that you may be looking for, I'm going to talk very briefly here about what Expedera has to offer. Our NPU architecture, which we call origin works from anywhere from 3 gigaops all the way up to 128 tops in a single engine and produces 18 tops per watt performance. Let me be very clear about how we come up with that number, because there certainly is a lot of specsmanship when it comes to numbers such as this. When we talk 18 tops per watt, we talk about running a ResNet 50 at int8 precision throughout the entire network in TSMC 7 nanometer, running at 1 gigahertz. Additionally, the 18 tops per watt number includes no sparsity, no pruning, or no compression, although we do support all of them. And perhaps most importantly, we have 70 to 90% utilization across standard industry networks. And what we mean by that is where a typical general purpose NPU or non-optimized NPU may only have 20 to 40% utilization. Our architecture, as it is specifically designed to be a neural processing unit, and it is specifically configured for the customer's individual workloads, we're able to maintain an average of 70 to 90% utilization of our processor, which leads to lower power, smaller area, and better performance. The core of our technology is packets. A packet is a continuous fragment of a neural network layer that contains the entire context of an execution. It contains information about the layers, the attributes, the priority of the particular packets, and provides data references. Essentially what we do is we manage the activations by looking at fine-grained dependencies of the different layers. We break down those layers into packets, and we stream those packets across the NPU in a way in the most optimum processing method possible. As you can see by the figure on the right, we're breaking down the layers, and then we're processing them rather in a way that is most optimum for the NPU. This allows us to lower power, this allows us to lower area, and this allows us to lower the amount of external bandwidth, if we need any at all, to provide the best possible system implementation. Expedera provides a customer-proven, developer-friendly software stack based on a TVM environment. It features mixed precision quantization. We can support customer-specific neural networks or custom layers within the software, as well as multi-jobs. This is certainly important when a customer of ours would like to run multiple networks concurrently for multiple different use cases. Absolutely can be supported. Our software allows an exploration into your FPS targets, your latency targets, and your power targets from the initial deployment or initial architectural phase all the way up to the production deployment. Let's very briefly touch on how Expedera's IP compares to others in the market and what our customers are seeing. The left-hand side of the chart here is an analyst comparison provided by Tech Insights Microprocessor Report, or Linley, demonstrating how different engines perform on a ResNet 50 in inferences per second per watt. Expedera, as you can see there, offers significantly better IPS per watt than products from NVIDIA, Qualcomm, or ARM. And on the right-hand side is a customer-reported silicon-based comparison, often viewed as the most important comparisons. In this particular case, our customer had an existing NPU as well as an existing 4K low-light video denoising algorithm. On their existing NPU, or former NPU as we're showing here, the customer was only able to get a very limited number of frames per second. When Expedera was deployed in their system, they were able to get 20 times the number of frames per second. Now, of course, the question might be asked, well, what was the cost of that? Well, it certainly wasn't power. As you can see from the lower part of the graph, the former NPU consumed more than twice the amount of power as the Expedera IP did, but of course, at less than 1/20th the frames per second. And to be fair, Both of these NPUs are in the same process node running at the same Fmax. So this is an apples to apples comparison. The result here is that when this particular customer deployed Expedera in their system, they got 20 times the frames per second at less than half the power. Significant user advantage, significant performance advantage. So let's summarize. In the buy or build argument, you should take a long, hard look at your big picture ROI. How much is it going to cost you to develop your own versus how much is it going to cost to procure a third-party solution? You need to account for all of your program needs, your product needs, the required efforts, and you need to look at software. You need to look at your schedule, and you need to look at how future-proof you need to make your system. And of course, we're biased. We believe you should consider a third-party, field-proven solution which gets you the best PPA for your workloads. And wrapping up here, Expedera's NPU is going to offer packet-based co-design, which enables determinism and high-performance compilation. We offer future-proofing on a level that many others do not. We can support new networks today, and we also support offload capabilities from our NPU in the rare occurrence that our NPU may not support the computations your future neural networks require. We configure our IP for a customer's network and workload needs without having to expose sensitive customer network details to us. We reduce your memory and your bandwidth requirements, and as mentioned, flexible multi-tenant deployments anywhere from 3 gigaops to 128 TOPS in a single engine. Thank you very much for joining us today. If you have questions, we'd love to hear from you at info@expedera.com. You can also visit us on the web at www.expedera.com. Thank you so much and have a great day.